Welcome to this session. In this session, we start describing each of the number systems we introduced in the previous session. So the first number system is the denary or decimal number system. So we say this is the most commonly used number system. Then so that's point number one. Point number two, it uses the simples, sometimes called digits. Zero, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the denary or decimal number system uses 0 to 9 simples, 0 to 9 digits, which are 10 simples in total, but digits from 0 to 9. And then next point, the place values. Place values are to the base place values are powers of 10, which gives a name. Denary. So denary means 10 or decimal. To the system. So this denary or decimal simply means base 10. So let's give an example. For example, two, 3, 7, 5.321 has place values so this you start counting. So this is the decimal point. So this number here after decimal point is 10 to power 0. This one is 10 to power 1. This one is 10 to power 2. This one is 10 to power 3. And then this one here is 10 power negative 1. This one 10 power negative 2. This digit 10 power negative 3. So which are this is the same as 1 over 1000. This is 1 over 100. This is 1 over, not really. So this the other way around. 10 power 3 is 1000. So this is 1000. This one is 100. This one is 10. This one is 1. This one is 1 over 10. This one is 1 over 100. This other one is 1 over 1000. So this is what defines the denary number system. Number two, let's discuss what we call binary system. Binary system means base is 2. So you say this system is widely used in all forms of switching applications and computer science. It uses two symbols, that is 0 and 1. And then place values are powers of 2, i.e. the system has a base of 2. Now I give an example. For example, if I have a number 1, 0, 1, 1.101 has place values. So I will be writing place values of each digit below it. So you start from here, the first digit on the left of decimal point, you write 2 power 1. This one is 2 power 2. This is 2 power 0, then 2 power 1. So the first digit, the power is 0. So you write power 0, this one is 2, this one is 3. Now this one is -1, this one is -2, this one is -3, i.e. 2 power 3 is 8, and then 2 power 2 is 4, and then this one is 2, this one is 1, this is 1 over 2, this is 1 over 4, and this is 1 over 8. So the number one zero 111.101 in binary system is equals to, you see this, you usually take digit multiplied by its place value. So it will be 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1 plus 1 times a half plus 0 times a quarter plus 1 times 1 over 8, which will be 8 plus 0 plus 2 plus 1 plus a half plus 0 plus 1 over 8. And when you add this, you get 11/5/8, or which is the same thing as 11.625 in the denary system, or in the normal number system. So that's what we have. So therefore, 1011.101 to base 2 is the same as 11.625 to base 10. Another example, given one zero one zero one 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 one, find its equivalent number in denary system. So this is what you do. Now this one, you don't have a decimal, so you write digits are 1 1 1 1, so these digits, and then 1 0 1 0 1. So these are the digits. Then place values. We start from the right. So write just 2 2 2 2 2 2 2 2, and then 2, and then 0 1 2 3 4 5 6 7 8. So the number will be 1 times 2 power 8 plus 0 times 2 power 7 plus 1 times 2 power 6 plus 0 times 2 power 5 plus 1 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. And then 2 power 8 times 1, you get 256, plus 0 plus 2 power 6 times 1, you get 64, plus 0 plus 2 power 4 times 1, you get 16, plus 8 plus 4 plus 2 plus 1. So then this would be 256 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. You get 351. So therefore 1 0 1 0 1 1 1 1 1 to base 2 is equals to 351 to base 10, or just 351. So that is how we convert from binary to decimal numbers. The next session will be studying about the next number system we call octal system.